Hello guys, welcome back to my YouTube channel. So I'm uploading a video after a long time. I know, sorry for this. So now in this video I'm going to show you how you can model a overhead reservoir in STAAD Pro software. So here you can see I have already modeled a overhead reservoir here. So now I'm going to show you in detail how you can do that. So this video is going to be very interesting video, so please watch the full video. Let's start. To get this type of video, please subscribe my channel and you will get this type of video in future and in various topic also. So if you have any topic in your mind, please let me know in comment section so that I can make a video on that topic. So let's start. Here you can see this is the section and plan of this OHR. So this OHR we are going to model in STAAD Pro software. So here you can see the hill beam diameter is given, that is 7.04 meter, and this is called hill beam, and this beam is called bottom ring beam and this beam is called top ring beam. And here you can see this is the cylindrical vertical wall, and this is bottom dome slab and this is top dome slab and this is conical shape slab. And here you can see these are the bracing beam basically, and there is a stair. So stair have a different isolated foundation here, and this column is connected with tie beam with this OHR. Okay, and here you can see using this stair you can reach in this walkway. So here is a walkway and also you can reach to the top of the dome slab, and using this ladder you can go inside this tank. So these are the structure we have to model it in STAAD Pro software. So these are the basic component I have just discussed. So now let's start one by one. So now I'm going to open a new STAAD profile. So say I'm giving a name OHR here, and now click here. I am keeping the unit meter and kilonewton for force unit, meter for length unit, and now I'm going to click on next and just I'm going to click on this finish. And now here you can see set the grid. So I'm not going to use grid here right now, so I'm going to close this. Now first we are going to create the node for column member. So here you can see the hill beam diameter is 7.04 meter. So this diameter is taken from center of this column to center of this column. So that's why if I want to create node for column member, suppose this is the 0 point in STAAD Pro software. So now this column center is situated at a 7.04 divided by 2 meter distance from this node along x-axis. Okay, so now first I'm going to create this node, then I'm going to repeat this node in circular way so that I can create all the node for all column member. So now let's do it here. So that's why I'm going to create suppose a node at 0 0 0. So now if I write here 0, and now here you can see a node is created at 0 0 0 coordinate, and here you can see the node number. So if you want to turn on the node number, just press shift plus n, or you can click on these symbols and label button, and here you can see in label tab you have to turn on this node number checkbox. And now here you can see one node is created at 0 0 0 coordinate, and now I'm going to just copy this node. Okay, so now here if you click on this view, so you will see the top view of this node, and now I have to create a node along negative x direction. So that's why I'm going to press Ctrl plus C for copy and Ctrl plus V for paste, and here I have to provide the distance, so along x-axis, but this distance would be in minus, and this should be 7.04 divided by 2, it's mean 3.52 meter distance. So now I'm going to write here 3.52 and now click on OK. And here you can see one node is created that is at a 3.52 meter distance. You can check the distance. So just click on this display node to node distance and now check the distance here. So here you can see the distance is 3.52. And now what I'm going to do, I'm just going to repeat this node 2 in circular way. So now just first click on this node cursor and then select this 2 number node and now click on this circular repeat button. And in this dialog box here we have to select axis of rotation, obviously y axis, because I want to rotate this node about y axis. So that's why I'm going to select here axis of rotation y, and here you have to mention the total angle. So total angle should be 360, and here you have to provide the number of steps including this, okay, not excluding this. So that's why here I'm going to count the number of columns. So here you can see the total number of column is 6. So that's why I'm going to give the number here 6, so that I want 6 number of node, okay, and the axis of rotation should be about y axis. And what will be the diameter here? The question is that. So actually the radius, it always will taken from 0 0. Okay, so as here there is no coordinate you are referring, so whenever you will use this circular repeat, so what will happen, it will repeat the node, okay, about the axis, whatever axis you will mention, and the radius will be considered from 0 0 to this node. So the distance from 0 0 point to this node is 3.52. so that's why we will get a circle of diameter of 7.04. so this is how it works. So now I'm going to click on this OK, and now here you can see the node is created. Now check what are the distance here. So from here to here distance, you can see this is 7.04 meter. So now here you can see total 6 number of node is created, and also these are the node for column member at foundation level. So now I'm going to create the column member first. So here you can see the column height is given. So first the depth of foundation is given here 2.5 meter, and then the tie beam are connected at a 4.6 meter distance, then 4.6 meter, and then 4.6 meter. So here the heel beam is situated. So the column are long from foundation to heel beam. So these are the height, this is the height of the column member. So that's why I'm going to provide this height for column member. So what I'm going to do, first I'm going to select all these node, and now I'm going to click on this translation repeat. So this option also is available in geometry option. So here you can see the translation repeat, and here you have to select global direction is y, because I want to repeat this node along y direction. And now here the number of steps should be 1 2 3 and 4. So that's why I'm going to select here 4. Here the number of steps should be 4, and here by default spacing I'm providing here 4.6, okay, and now the first step spacing should be 2.5. so that's why I'm going to edit this and writing here 2.5, and now next spacing should be 4.6, then next spacing should be 4.6, and the next spacing should be 4.6. so like that. So that's why I'm keeping this distance 4.6, and here I'm going to turn on this link step option so that column member is automatically created. And now I'm going to click on this OK, and now go to the isometric view, and here you can see the column nodes are created, okay. So but one thing is that at 0 point there will be no column member, so I'm going to delete this column, and also I'm going to delete the nodes also. So now here you can see only this 6 column is created, and just check the distance here. So first distance is 2.5, should be 2.5 here you can see, and next spacing is 4.6, next one is 4.6, and next one is 4.6. And now what I'm going to do, I'm going to connect this tie beam at GL level, then at 4.6 level, like that I'm going to connect this tie beam. So that's why what I'm going to do. So first let's do one thing. First provide the support here. So these are the node at foundation level. So now I'm going to select this, and now I'm going to click on this support page, or you can directly click on this comment, and here support specification, and here you can select fixed. So now I'm going to assign here. So now here you can see the support I have assigned here. Okay, and now I'm going to select the node at GL level. Okay, and now click on this view, then view selected object only. So here I can see only the node at GL level. So now I have to connect the beam, okay, like this. These are the tie beam, these are the basically bracing beam I have to connect here. So what I'm going to do, I'm going to click on this add beam button. This is also available in geometry. Then click on add beam, this add beam from point to point. Okay, then first select the node first here. So this is the first node, this is the second node. So now I have created one beam member here, and now I'm going to select this beam member, and I am going to also use the circular repeat option here. So click on this, and the axis of rotation should be Y, and number of repetitions should be 6. And now just click on OK. Here you can see the beam are automatically created. Okay, and what I'm going to do now, I'm going to repeat this beam at different height. So that's why I'm going to just click on this whole structure. Okay, and here now I'm going to click on this translation repeat, and here I'm going to select the global direction, that is Y, and the number here should be 1 2 3. So it should be 3, and what should be the spacing here? Here the spacing is mentioned, that is 4.6. So this should be 4.6. And now just click on this OK button, and here you can see the beam member is created. And but in this level, at heat level, these bracing beams shouldn't be there, right? So here you can see only the heel beam is there. So that's why what I'm going to do, I'm just going to delete this beams here. Okay, so now if you see the render view, you can see, so these are the column and these are the beam I have created. Now I'm going to assign the property here. So to assign the property, first you have to select the members. So now I'm going to select all the column member. So just click on this select and go to the option beam parallel to y-axis, and here you can see all the column member is selected. And now here the diameter of the column is not mentioned. So suppose I am assuming the diameter of the column is 500. So now click on this property page, and here click on this define tab, and here I have to provide here circular column. So that's why I'm going to click on this circle, and now here I'm going to provide the diameter, and here the diameter is 500 sec, and just click on this assign button, and here you can see the section is assigned in column member. And now here I'm going to provide the tie beam dimension. So to select the all tie beams, just click on this select, and then select here the by missing attribute and then click on missing property, and here you can see the all the tie beams are selected. And now just click on this see define, and here the select option rectangle, and here just provide the dimension of the tie beam. So in drawing here you can see the dimension is given, though the dimension we will provide as per our design. So initial diameter dimension we are providing say 400 by 600, where 600 is the depth and 400 millimeter is the width. And just click on this assign, and here you can see the tie beam properties is assigned. And now just click on this close and see it in render view, and here you can see the property of column and tie beam member is assigned. And if you want you can create the group for column member and also tie beam member. So create group, just press Ctrl plus G, and here name the, suppose this group is for column member, so I'm writing here C1, and this should be select type should be beam, then click on OK. And now here you can select the column member by property option, I mean go to the select menu and then click on this by specification, then click on this property name, and here to click the circle property, then all the column member is selected. And now just close this, and now here click on this associate tab, and here you can see the all column member are assigned in this C1 group. And if you also want to assign all bracing beam in a different group, then you can create a group say name TV, and then select type should be beam, and just click on this OK. And to select the bracing member here, just go to select and select here by inverse, and then select inverse beam selection, and here you can see all the tie beam is selected. And now just associate. So to check whether group is created correctly or not, so just click on this C1 group and click on this highlight. Here you can see only the column member is highlighted. And now if you select this tie beam group and then click on select, here you can see only the tie beam member is highlighted. So this group may help you when you will design this member, it may be help for you. So because you know here we also add different beam member here, and also we will provide here element also, so that's why it will be easy to identify different member if you create a separate group for them. So that's why I'm suggesting you to create group for different member, so that when you will design you get the advantages, and you can easily identify them, and you can save your sometimes. So that's why I've done this. And now what I'm going to do, now I'm going to create this slab by using element member. So to do that, so what I'm going to do, so first let's see, first I'm going to create this bottom dome slab. So how can we do that? So to create the bottom dome member, you need to click on this geometry tab, and then you have to click on this run structural wizard. So whatever element I'm going to add here for this wizard, I'm going to use structural wizard. So by using structural wizard you can easily model this wizard. So that's why what I'm going to do, just click on this run structural wizard, and here you have to select model type here surface or plate models, and here you have to select spherical surface. So before open this dialog box, let's study the drawing first. So here you can see the radius of this dome is given. So here two radius is given, the inner radius and outer radius. So since we have to model along the center line, So that's why what I'm going to do, I'm going to take the average radius. So here the radius of the outer line is given 6.7 meter and radius for inner line is given, that is 6.2 meter. So if I can, if we take the average value, so that should be 6.45 meter. So this value you should note down, this value will be used over there. And also you need the base diameter, and here you know the base diameter is 7.04. so here the radius we get 6.45, then we have to calculate the diameter of it, so diameter will be 12.9. so now we get the diameter of this dome, and also the base diameter we get, that is the diameter of this heel beam, that is 7.04. now what I'm going to do, open this structural wizard, and again now select this surface slash plate model, and now click on this spherical surface, and here diameter of sphere we have to provide, that is we got 12.9, and also here the base diameter should be 7.04, and here you have to provide the division of the plate. So here the division should be like that, here number of column is 6. Okay, so along longitude direction you should be provide the division which is multiple to 6, otherwise what will happen, otherwise the column point will not connect to the plate element, so you may get error, or also what will happen, the load transfer will not happen in column member. So that's why you have to divide the plate member along longitudinal direction so that the plate node is merged with column node, otherwise what will happen, otherwise column node will be in between plate node, so what will happen, the load transformation will not happen. So that's why you should provide the division which is multiple to the column number. And now, so that's why I'm going to provide here the division is 24, which is multiple of 6, and so just that's why I'm keeping this value. And here the division for latitude, it may be any value, but you should be aware about that, the what will be the plate size, missing plate size, that shouldn't be a badly shaped plate. Okay, so you know, if you divide the longitude in 24, so if you increase this value too much, what will happen, the plate size may not be a regular shape, it may be a badly shaped plate. So that's why you have to maintain also this value, so that the plate are almost square size or in rectangular size. But if you increase this value, what may happen, the plate may be a rectangular size but whose length will be more higher than width, so that time you may see the badly shaped error warning, badly shaped plate warning. So that's why you should keep it in a range, so that you don't see the badly shaped plate warning. So now I'm going to just apply here, and here you can see the plate is meshed automatically, and here you can see the size of one plate and it's look like good. Suppose if you just double click here, this dialog box will open again. Suppose if you increase this value, say I'm increasing is 50, and now here you can see the length of this plate is too much, length of this plate is higher than the width, and this is too much high value. So if you provide this type of plate in your model, you may see the badly shaped plate error. So that's why what you will do, you will provide a value so that all the plate shape may be a square. near equal to square plate size. So that's why I'm just going to provide here 8, so that here you can see the plate size is almost okay, and here also the plate size is almost okay. Okay, so that is very important when you are assigning, when you are adding element member in your model. So, and also I'm going to show you, suppose here I'm providing a division value which is not a multiple of 6, 28 I'm just providing here. Okay, and now what will happen, so here also the missing, you can see the okay, it is okay. And now just click on, just close this box and just click on yes here, and here you have to provide the y value. So I don't know what is the coordinate of this node, so that's why I'm just providing a arbitrary value here, suppose 30 meter. So that value will be from 0 0 0 coordinate. So now I'm just providing here 30, and now just see the coordinate here. Here the coordinate is 16.3, and here the coordinate is 35.45. So this is 35.405 minus, and what is this value? This value is 16.3 minus 16.3, so this is coming 19.105. so now I have to move this all node, just select this node and press F2 button for shortcut of move command, and here just put the y value here. This should be 19.105, this should be minus 19.105, and here you can see, so just ignore this option right now. Okay, and here you can see, just I'm going to show you one thing. See, only here, see, this column node is not connect with this plate node. So this is happening only because I have provided division value which is not multiple of 6. So if I provided the division value which is multiple of 6, just delete this, and now I'm going to create again this. So just click on geometry and just click on run structural wizard, here again surface and plate, and here provide these values. This should be 12.9 and this is 24, it is okay. And now just click on this close, and just I'm going to click on yes, I'm going to provide here 30, and now I'm going to move it, and here it is 35.405, and this is 16.3, 19.105. so I have to move it 19.105 minus 19.105, and now here you can see, so this option is coming only because some node already exist in that position. So that's that at the column node, and here you can see only the 6 node option we are getting. So that's mean all the plate node coincide with the column node. So that's why we are getting list of duplicate node here. So what I'm going to do, just I'm going to do merge this node. Okay, and here I'm going to select this option, delete the second node, because first node is the column node and second node is the plate node. So that's why I'm going to delete the second node, I'm keeping the first node, and just click on this OK option and then select yes. Okay, and here you can see all the plate are perfectly connected with the column node, and there are some different node is there, but that is not the, that node will not be connected with the column node obviously. So here I have to provide a ring beam, so this node will be connected with a ring beam, and here each column is connected with the plate node. And also you can see the render view here, and here you can see also that all the plate node is connected with the column node perfectly. So that's why you have to calculate those division, so that the plate are perfectly connected with the column member. Since this video is going to be a lengthy video, so I'm going to cover the rest part of it in another video. So I'm going to ending this video here. So if you find this video is helpful for you, please like this video and share it to others, and also subscribe my channel to get this type of video in future. Thank you.